Hi, my name is Arjun Sharma, and I'm presenting our CS410 final project. We use sentiment analysis to grade NBA scouting reports. So, scouts write yearly articles every year predicting how players will do once in the NBA. There's no real way to check how accurate those reports are. So, what we did is use sentiment analysis to quantify exactly how accurate those scouts were. And the steps we used was to first query Google to grab the most relevant scouting reports. And this kind of took a little playing with. And we used article summarization. And then we performed the sentiment analysis and averaged into the one score. And then we compare that score to the player efficiency rating of the player once they were actually in the league. And the importance of the query was that we had to make sure that we were grabbing relevant scouting reports, and we needed to make sure that they were relevant and that they were written before the player was actually drafted. Because one of our issues earlier on was getting players scouting reports or articles that were after the player was drafted. And so this is an example of our screenshot of our front end of the actual website we designed. And as you can see here, we have all the players in the 2012 draft. And if you pay attention to the number 16 pick, Royce White, I'll show you in a graph later. So actually, in the sentiment analysis, we used Node.js's natural library to perform it, and we were able to average all the sentiments to create an overall sentiment score for a player. And this graph shows that what the results we got are actually very good because, as you can see, the top 10, the top 5 are very good. But if you look at the 16th pick, that was Royce White. It's really low because of a criminal activity, and he had a lot of off the court issues, which we feel unfairly biased his negative sentiment score. And this is why the sentiment was so low, even if maybe it shouldn't have been as low when he was compared to when he was actually drafted. So this kind of shows where that what we did was worked well, but there are some ways that we can improve it in the future to make it even better. So once we had the sentiment, we were able to compare it to the actual performance, and we settled on the player efficiency rating, which is a really good singular statistic that really calculates how well a player is done in the league. And we found, as the graph shows, that the sentiment does a very good job of creating the actual sentiment of the player. Um, However, the problems are that the sentiment library doesn't tune to basketball lingo. Like something like deadly accurate shooter would get a score equals 0, and even though that's a good thing, and Google banned us for querying too much, and sometimes there are not enough articles for lower draft picks, and a lot of the sites don't have consistent HTML markup. So the further work we could do is to try to actually grade a specific scout's track record to see if certain scouts are better than others. Because usually in crowd knowledge, people are pretty accurate. So maybe if we would look at a specific scout's track record to see if they do a better job than others, we could really grade how certain scouts do.
Hi, my name is Chris, and I will be demonstrating our project for CS410. As you see here, here's our dashboard, and the question right now is which draft class we want to go to. In this demo, I will type in the year 2012 and put that. And here we have a list of players from the draft class of 2012. It has their round pick and career points. Um, Once we select a player, I chose Anthony Davis. You can go into inspect element, and then we wait for our backend to load. As you see here, an object has been loaded. For Anthony Davis, we have 200 documents. Each document contains a description of the document, the title of the document, and a sentiment object. I'm just going to click on the sentiment object here, and we have the amount of negative words, the amount of positive words, which are currently 0 for this document, and the different amount of tokens. That score up there is 0 right now for this document, which essentially means that it is not positive or negative. As we move along, here's another article, and we see here our sentiment value is 1. Our negative words are no, and our positive words are prospect. So this is the end of our project demo, and as you see here, we've queried about 200 documents, and we have sentiment scores for each document. In addition to this, as well in our backend, we had a feature where we used a naive Bayes classifier to look at past documents and past document scores and compare that to players in this draft to see and predict how they would do. One of the major issues that we had and we came across with was that Google would block our queries when we query too much, and seeing as there's 60 players in a draft class for the NBA for a specific year, we found that often Google would block us, which would definitely hamper the amount of time it took for us to query all the documents, and it was hard to get around, and we weren't able to actually create it in a dynamic setting that we have right now for just querying a single player. So thus we decided to ditch that one functionality, but creating a naive Bayes classifier is something that with our code set up right now could easily be done. Really, it was only just a couple extra lines that we had it implemented, but we decided to take it away due to the problems that we had with Google.